suppose you have p of x equals x cubed plus 5x squared plus 30x minus 36. First thing I'll say is any integer you can use to factor p of x has got to be a factor of 36. What do I mean by an integer you can use to factor p of x? I mean, if you use 1 to factor p of x, that means that x minus 1 is going to be a factor. If you use minus 1, x plus 1 is going to be a factor. If you use 2 to factor it, either you're going to have x plus 2 or x minus 2 as factors, and so forth. Okay, why is that? Well, just as an example, let's say you got x minus 3, it's going to be x minus 3 times x plus 4, well, let's say x plus 6 times x plus 2. There's a factoring of a polynomial. It's not this polynomial. Okay, but if you expand this, this equals x cubed, because you got x here, and x here. And then you got a bunch of other stuff. And then at the end you got this times this times this. 3 times, negative 3 times 6 times 2. Negative 3 times 6 is negative 18. You multiply that by 2, you get negative 36. And of course these are your factors. All these numbers divide into 36. Okay, 3, 6, and 2 divide into 36. We don't worry about the pluses and minuses. When we find the factors, we take care of that down here, as we'll see. Okay, so my point is any integer you can use to factor this thing is going to be a factor of 36. Okay, just because of the way these factors multiply together to give you this polynomial. We assume that the polynomial has factors. It might not. Actually, if it's a cubic polynomial, it has at least one factor, and we'll see why in a minute. Okay, so we start looking at factors of 36 to see if any of them make this 0. And because, of course, if x minus 1 is a factor of this thing, for example, then when x is 1, that factor is 0, and the whole polynomial is 0. Okay, so we look for numbers that make this 0. And we kind of hit the jackpot right off on this one. We try 1. That's the smallest factor, 36. It's the easiest number to check. Okay, we don't necessarily expect it's going to work, but we try it. So we plug in 1, we get 1. Here we get 5, here we get 30. Let's see, that adds up to 36. Subtract 36, we get 0. So we hit the jackpot. Plus 1 is a factor, is a 0 of p of x. So we say p of 1 is this, it's 0. Okay, so we say that 1 is a 0 of px, of p of x. If 1 is a 0 of p of x, it's a number that makes p of x 0, then x minus 1 is a factor of p of x. Because, of course, if you let x equal 1, x minus 1 is going to give you the 0. That's how x minus 1 has to be a factor, okay. Don't want to go into too much detail on that, but that's how it works. Whether you understand how it works, and it's best if you do, because you're less likely to forget it, more secure on a test, and so forth. Whether you understand why it works, whether or not you understand why it works, understand that it works. Okay, so what we've done is we've tried factors of 36. 1 is the first one we tried. We hit the jackpot, it gave us a 0, so x minus 1 is a factor of p of x. To find the other factor of p of x, we divide x minus 1 into x squared plus 6, into our polynomial, and by doing the long division, we get this result, x squared plus 6x plus 36. So now we know that p of x equals x minus 1 times x squared plus 6x plus 36. Well, we'd better hold off a minute and see how the long division works. This is something everybody's seen by the time they get to this course, but if you haven't used it in a while, you need a review. Even if you've used it recently, it doesn't hurt to reinforce it. So we have x minus 1 divided into this. X goes into x cubed, x squared times. If you divide x cubed by x, you get x squared. So we put x squared up here, and what that does is then when we multiply x squared by x minus 1, we get x cubed minus x squared. Now, remember the long division algorithm. I could explain why this works, but I find that at this level people generally don't want to know and don't need to know and have a hard time understanding it. Okay, so we divide the x into x cubed, we get x squared. We multiply x squared by x minus 1, we get x cubed minus x squared. Now this little minus and plus sign here are there to remind us that we're subtracting the x cubed minus x squared from this. So we put a little minus here and a little plus here. We subtract a negative x squared, we're adding x squared. So that x cubed and minus x cubed gives us 0. 5x squared minus negative x squared is the same as 5x squared plus x squared, giving us 6x squared. And then we bring down our 30x. And now we divide x into 6x squared, we get 6x. Multiply that by the x minus 1, we get 6x squared minus 6x. We subtract that expression by changing the signs. The little red signs here indicate a reminder that we're actually doing 6x squared minus 6x squared and 30x plus 6x to get 36x. Bring down the negative 36. Divide x into the 36x, we get 36. Multiply 36 by x minus 1, we get 36x minus 36, which is identical to this. So when you subtract, you're done, and you have no remainder. Well, there's our long division. Now, if you divide one number into another, the result multiplied by the number you divided by gives you that quantity. So since this divided into this gives you this times this gives you this. That's why P of x equals this. Okay, now, you have x squared plus 6x plus 36. We can't seem to factor this. You try. You could try x plus 1 times x plus 36, x plus 2 times x plus 18, x plus 3 times x plus 12, and some minuses in there. You're never going to get a 6x. Okay? You're never going to get a 6x. Because if you did, then this would factor into two factors, like it was x plus 12 and x minus 3 worked. Well, the x minus 3 would be 0 if x is 3. X plus 12 would be 0 if x is negative 12. So you'd have two zeros, two numbers that make this 0. And you don't. You can't. Why? Well, let's check the discriminant. The discriminant of this expression is b squared minus 4ac. And for this expression, that's 6 squared minus 4 times 1 times 36. You can do that yourself. That's negative 108. Well, that's a discriminant, meaning that if you use a quadratic formula, you find that this is equal to 0 for only two complex conjugate numbers. Square root of negative 108 is not a real number, and that's part of your result from the quadratic formula. So this negative here indicates that this isn't factorable. Now, negative 108 then tells you that this isn't 0 for any real x. It follows that x squared plus 6x plus 36 can't factor. Okay? We can look at the graph now of this function. So what we know is p of x equals this polynomial that we just factored by long division and by finding a zero. Factors as p of x equals x minus 1 times x squared plus 6x plus 36, which we just saw. Little terminology. X minus 1 is a linear factor. X squared plus 6x plus 36 is an irreducible quadratic factor. Irreducible because it has no zeros. It can't be factored. It can't be reduced to two factors over the real numbers, at least. So, what we did previously, just to summarize, we found the factor x minus 1 from the fact that p of 1 equals 0. We plug in 1, we get 0 for this polynomial. It tells us x minus 1 has to be a factor. Long division then gave us the x squared plus 6x plus 36, and the discriminant showed us that x squared plus 6x plus 36 is unfactorable. So there is our totally factored form of p of x. So we graph the function. We know it has a 0 at 1. We plug in 0, and we're left only with negative 36. So that's our y-intercept. So we have to go through here, we have to go through here, and the graph has to look basically like the graph of x cubed, except near the kind of center of that graph where it can fluctuate a little bit. So here we have the white graph, goes through this point, comes up, starts to try to level off, but doesn't quite, and goes on. And then we have this green graph that pretty much follows the same path up through here, and then diverges by wiggling. You got a relative maximum here, a relative minimum here, so you got a couple little wiggles in the graph before it goes on, and we'll join up with this possibility. There's a lot more I could say about the wiggles. There's a lot more we could say about other things, but I'll just say that we don't know if it's got this shape or this shape. And the easiest way to figure out which kind of shape it has is to use calculus. And in pre-calculus, we can't use calculus. And there are ways that we could do it to an extent without calculus, but they're a lot harder than calculus. So we're not going to mess with it. So here are two possible ways you could draw the graph. So one method for factoring a polynomial, to summarize, you find the factors of the constant term. And by the constant term, what do I mean? Well, I mean the negative 36 in this case, the term that isn't variable. It doesn't have an x in it. This is constant. No matter what x is, this is negative 36. So you find the factors of the constant term, see if any of those factors make p of x 0. You do the long division by x minus c, where c is the number that makes the polynomial 0. The factor of 36 that makes this thing 0. And then, if possible, after you've done the long division and expressed your result as a product of x minus c and whatever you get by the long division, you continue factoring. So we did the long division, we got this. We checked to see if it was possible to factor this. When you look at it, you can't tell immediately unless you have looked at a lot of these things whether it's factorable. We find in this case that it's not factorable, but you know that something that looks like this could well be factorable. If it was x squared plus 6x plus 9, you'd be able to factor it. X squared plus 6x plus minus 7 would be factorable. X squared plus 6x plus, well, x squared plus 6x plus 5 would be factorable. Many other expressions could be factorable. But the one we get here isn't. Okay, so there's a method for factoring a trinomial and something about the implications for the graph of the trinomial. It's not a trinomial, sorry. For factoring a cubic function, tri-cubic, getting late in the day. So again, to factor cubic, you follow this process. In the case of this one, where we have this irreducible quadratic factor, we have a graph that's going to either look like this or like this. Okay. I go into more about why it has only 2 turning points, but for right now we're just doing an introduction, and you're going to get that in your regular pre-calculus course.